Hello everyone, welcome to FosterJEE. So today I'm going to start our second lecture of organic chemistry, that is classification and nomenclature of organic compound. In this particular chapter, we will be discussing the classification of organic compound and the nomenclature of organic compound. Nomenclature means the naming of organic compound. So, let's start with the classification of organic compounds. So, organic compounds have been classified on the basis of two categories. First one is on the basis of structures, and the second one is on the basis of functional group. We will discuss each category one by one. The first category is based on their structure. So, organic compounds on the basis of their structures are classified into two categories, that is acyclic compounds. Here, the acyclic compounds are the compounds in which the carbon atoms are linked to each other in such a manner that the molecule is having a open chain structure. That is why it is known as open chain compounds. The other name of acyclic compound is aliphatic compound. So, the acyclic compounds are the open chain compounds. They are subdivided into two categories, that is saturated compounds and unsaturated compounds. Here, saturated compounds are the compounds in which carbon atoms are linked with a single bond. And unsaturated compounds are the compounds in which hydrocarbons are linked with either a double bond or a triple bond. So, the acyclic compound or the open chain compounds are either a linear structure or a branched structure. So, branched structure is when carbons are attached in branched form, and linear structure is when carbon atoms form a straight normal chain. So here we can see that here three carbons are attached in a straight chain, so it is a linear structure, and when another carbon is attached with this straight chain, then this is a branched structure. Now moving to the next category, that is cyclic compounds. So the cyclic compounds are the compounds in which carbon atoms are linked in such a manner that the molecule has a closed chain structure. That is why it is known as closed chain compound or a cyclic compound. So, a cyclic compound may have one or more than one ring present in it. So, if a cyclic compound contains one ring, then it is known as monocyclic compound. And if it possesses more than one ring, then it is known as polycyclic compound. So polycyclic means either it is dicyclic, tricyclic or tetracyclic compounds. All are known as polycyclic compounds. Now the cyclic compounds is further divided into two categories. First one is homocyclic compound and the second one is heterocyclic compounds. So let's discuss these in detail. So cyclic compounds are divided into two categories, that is homocyclic compounds, which means that these are the compounds having rings of carbon atoms only. That is why the homocyclic compounds are known as carbocyclic compounds, because they formed by the rings of carbon atoms only. And the heterocyclic compounds are the cyclic compounds having ring built up of more than one atom. So the most common atoms are oxygen, nitrogen and sulfur. So here in heterocyclic compounds, the compounds form ring which built up of more than one atom. Examples are pyridine. Here we can see that in pyridine, it contains nitrogen atom other than carbon. And the other example is indole. Here in indole we can see that nitrogen is present other than carbon atom. So it is a heterocyclic compound. Now the homocyclic compound is further divided into two categories, that is Elecyclic compounds and aromatic compounds. So Elecyclic compounds are the compounds which contains rings of 3 or more carbon atoms. So Elecyclic compounds are the compounds which contains rings of 3 or more than 3 carbon atoms. It resembles with aliphatic compound. That is why it is known as elecyclic compound. That is aliphatic cyclic compound is shortened to elecyclic compound. It is also known as polymethylene compound because more than 3 methylene groups are attached with each other in a ring form. That is why it is known as polymethylene compound. The examples are cyclopropane, similarly cyclobutane, cyclohexane and cyclopentane. Now the aromatic compound. So aromatic compounds are the compounds which consist of conjugated planar ring system which accompanied by the delocalized pi electrons. It follows the Huckel rule. That means the system should possess 4n plus 2 pi electrons in the rings. It is divided in two categories. First one is benzenoid compound and the second one is non-benzenoid compounds. So the compounds consist of at least one benzene ring is known as benzenoid compound. So here benzenoid compounds consist of one or more benzene ring. Examples are phenol. Here in phenol we can see that the benzene ring has a substituent group OH. The second example is benzenoic acid. Here the substituent group is carboxylic acid. Now, there are some aromatic compounds which have structural unit different from the benzenoid type. These are known as non-benzenoid compounds. For example, tropolone. Here, in tropolone, we can see that benzene ring is not present in the compound, but it follows the 4n plus 2 pi electron rule. That is why it is aromatic in nature. Now we will discuss the classification on the basis of functional group. So first we will understand what is functional group. So functional group is an atom or group of atoms represents in a molecule that gives the molecules its characteristic chemical property. So it means that all the functional group have different chemical properties. So on the basis of functional group, the organic compounds are classified into 20 categories. First one is alkane. Here the carbon atoms are linked with a single bond. So they are known as alkane. These are the saturated compounds. Now the second category is alkene. Here carbon atoms are linked with a double bond. It have a general molecular formula of CnH2n. Third category is alkyne. Here carbon atoms are linked with a triple bond. The next one is halides, having the functional group X. Here X represents the halogen group, that is fluorine, chlorine, bromine and iodine. Now the next one is alcohol. Here in alcohol the functional group is OH, which is attached with an alkyl radical. The next one is thiol. Thiol is similar with alcohol where the oxygen is replaced with sulfur atom. So here the functional group is SH. Now the next is aldehyde. Here in aldehyde the functional group is CHO group, where CHO group is linked with alkyl radical. Now ketone, having CO functional group, where two alkyl radicals are linked with one CO group. Now in thioketone, oxygen is replaced by sulfur. Here CS group is the functional group which is linked with two alkyl group. In carboxylic acid, the COOH group is linked with one alkyl group. Now ether. In ether, two alkyl radicals are linked with one oxygen atom, and here the functional group is oxygen. Now thioether. In thioether, the functional group is sulfur, which is attached with two alkyl radical. Now in sulfenic acid, one oxygen group is replaced with sulfur to form sulfenic acid. Here the functional group is CSOH. Now in amide, the functional group is CONH2, which is connected with one alkyl radical. In amines, the functional group is NH2 group, which is connected with one alkyl radical. In nitriles or cyanides, the functional group is CN, which is linked with one alkyl radical. Now in nitro, the functional group is NO2 group, which is connected with one alkyl radical. Now the next one is ester. In ester, the functional group is COOR. So here the COO group is connected with 2 alkyl radical. Here in thioester, the functional group is COS, which is connected with 2 alkyl radical. Now the acid halides. Here in acid halide, the functional group is COCl group, which is connected with 1 alkyl radical. So these are the classification of organic compound on the basis of functional group. Now we will discuss the nomenclature of organic compound. So nomenclature means the assignment of names to the organic compounds. So there are two main systems of the nomenclature of organic compound. The first one is trivial system and the second one is IUPAC system. It is pronounced as IUPAC system. Trivial system is the oldest system of naming a compound. So whenever a new compound is discovered, it was given an individual name. These are the common names of the compounds based on the source from which they are obtained. For example, formic acid. So, formic acid is derived from the Greek word formicus, which means red ants. So, the formic acid is obtained from red ant and the Greek word for red ant is formicus. That is why the common name of formic acid is derived from formicus. Now the another example is acetic acid. It is derived from Latin word acetum, which means vinegar. Now, IUPAC system is the International Union of Pure and Applied Chemistry system. A student must be familiar with both the common names as well as the IUPAC name. So, we will discuss each system one by one. Trivial system is not that important from the point of examination. So let's take a quick discussion on trivial system. The first one is saturated hydrocarbons. These are also known as paraffins. The general formula for saturated hydrocarbon is CnH2n plus 2. So the saturated hydrocarbons or alkanes are the hydrocarbons containing only hydrogen and carbon. These are single bonded hydrocarbons. And the suffix used for paraffins are ane. So the name of the compounds are methane, ethane, propane and so on. Now let's discuss some prefix based on the chain isomerism. So the first prefix is prefix N. It is used for continuous chain, or we can say that for a normal or a straight chain. So here we can see that there are 4 carbon atoms linked in a straight chain. Here it is saturated hydrocarbon. So butane is used as a root name. Ane is the suffix for saturated hydrocarbons and the prefix used is N. So the name of the compound is N-butane. Similarly, the name of this compound is N-propane because there are 3 carbon atoms linked with single bond. Now the next prefix is prefix iso. So when one methyl group is attached with the carbon chain, then iso is used as a prefix. So here we can see that there are 1, 2, 3, 4 carbon atoms. So it will be butane, and here one methyl group is attached with the straight chain. So it will be isobutane. Similarly for this, the name is pentane and the prefix is iso. So the name of the compound is isopentane. Now the next prefix is neo. When 2 methyl group is attached with same carbon atom of a carbon chain, then neo is used as a prefix. So here we can see that the number of carbons linked with each other are 5 carbon atoms. So the root name will be pentane, and here 2 methyl groups are attached with the same carbon. So the prefix used will be neo. Now, one more important thing is there are 4 types of carbon atoms in carbon chain. The first one is primary carbon. Second one is secondary carbon. Similarly, tertiary carbon and quaternary carbon. So, when a carbon is attached with only one carbon, or no carbon, then that is known as primary carbon. And secondary carbon is when carbon is attached with 2 other carbons. Tertiary carbon is when carbon is attached with 3 other carbon atoms. Similarly, quaternary carbon is when carbon is attached with 4 other carbon. So, primary carbon is also known as 1-degree carbon. Secondary carbon is known as 2-degree carbon. Tertiary carbon is known as 3-degree carbon. And quaternary carbon is known as 4-degree carbon. So let's understand this with an example. Here we can see that in this compound, this carbon atom is linked with one carbon atom. So this is a 1-degree carbon or a primary carbon. Here this carbon atom is linked with 2 other carbon. One is this one and one is this one. So this is a 2-degree secondary carbon. Here this carbon atom is linked with 3 carbons. 1, 2 and 3. So it is a 3-degree carbon. Now here this carbon is linked with 1 carbon. So it is 1-degree carbon. This carbon is linked with 1 carbon. So it is also 1-degree carbon. This carbon is linked with 1 carbon. So it is 1-degree carbon. This carbon is linked with 1 carbon. So it is also 1-degree carbon. Now this carbon is linked with 4 other carbon atoms. 1, 2, 3, 4. So it is a quaternary carbon atom or a 4-degree carbon. Now let's understand the alkyl group. So alkyl group are the radical or group obtained from the removal of one hydrogen molecule from the paraffin or alkene, we can say. Here we can see that this is paraffin having molecular formula CnH2n plus 2. So when there is removal of one hydrogen atom from paraffin, The radical formed is known as alkyl, having molecular formula CnH2n plus 1. The suffix used for alkyl is YL, il. So here we can see that the molecular formula for methane is CH4. So when one hydrogen is removed from methane, then it forms CH3, which is an alkyl radical. So here the name of this compound is methane, where suffix is ane. And we know that the suffix for alkyl group is il. So the name of CH3 will be methyl. Similarly, ethyl, propyl, and so on. Now, the next one is unsaturated hydrocarbons. So, there are two types of unsaturated hydrocarbon. First one is olefin, which are double bonded hydrocarbons. And the second one is acetylene, which is triple bonded hydrocarbons. So, olefins are the double bonded hydrocarbon group having two hydrogen less than paraffin. That is why the general formula is CnH2n. Here, the suffix used for olefin is ylene. So, we can see that when two carbon atoms bonded with one double bond, then the name is ethylene. These are all the common names of the compound. Similarly, when carbon atom is linked with three other carbon with a double bond, then the name is propylene, because the suffix used for olefin is ylene. Okay, now the alkynyl are obtained from alkynyl group. It is similar to alkyl radical. So alkynyl group are obtained from the removal of one hydrogen from alkene. Okay, we can show it by a chemical reaction. Here CnH2n minus one hydrogen. Then it will form CnH2n minus 1. This is alkynyl group. And the suffix used for alkynyl is enyl. So the name of C2H3 is ethenyl. Similarly, propenyl for C3H5. It is also known as vinyl, and this one is known as allylic group. Now, moving to the acetylene group. Here, acetylene compounds are the compounds having triple bond. So, here 4 hydrogen less than the paraffin compounds. That is why the general formula is CnH2n minus 2. Now, for acetylene, the suffix used is acetylene. That is why the name for this compound is acetylene. When one methyl group is attached with acetylene, then the name of the compound is methyl acetylene. So here we can see that the suffix used in acetylene is acetylene. These are the common names. Now moving to alkyl halides. So here monohalogen derivatives of paraffin, where one alkyl radical is bonded with a halogen group. They are obtained from the replacement of one hydrogen atom from the paraffin by the halogen atom. So the general formula for alkyl halide will be CnH2n plus 1X, where X is fluorine, chlorine, bromine and iodine. Now the common names are obtained by naming the alkyl group and adding the halide group. So the name of the compounds will be like this. For example, CH3Br. So the name of this compound is methyl bromide. Here we are naming the alkyl group and adding the halide group to name the compound. Similarly, this compound C2H5Cl is ethyl chloride. If more than one halogen is attached with the carbon, then di, tri, tetra are used. For example, CHCl3. The name of this compound is carbon trichloride. Okay, now the next category is alcohol. So, alcohols are the hydroxy derivative of hydrocarbon having functional group OH. These are known as alcohol. So, these compounds are obtained by the replacement of one hydrogen atom by the hydroxyl group. It is classified into three categories: mono alcohol, dialcohol or trialcohol. So, for example, in methane, one hydrogen is replaced by one hydroxyl group to form CH3OH. So the name of the compound is methyl alcohol. This is the common name of the compound. Here the suffix used is alcohol. Similarly, we can say ethyl alcohol, isopropyl alcohol. For example, here we can see that the OH group is present in the iso position. So the name of the compound is isopropyl alcohol. Now the next one is ether. Here in ether are the compounds containing two alkyl group attached with oxygen atom. So the functional group is ROR. Here R and R are the alkyl radical. It can be similar or different. So for example, if one compound is CH3O C2H5, then the name of the compound is ethyl methyl ether. The suffix used in ether is ether. If the compounds are similar, for example, CH3 is bonded with OCH3, so the name of the compound is dimethyl ether. Now, moving on, the next is aldehyde group. So here, these are named after the names of acid which they are produced on the oxidation, and the ic is replaced by aldehyde. For example, HCHO. So here we know that HCOH is the formic acid. So the IC is replaced by aldehyde and the name of the compound is formaldehyde, because the suffix used in aldehyde is aldehyde. Similarly, acetaldehyde or propionic aldehyde. Now the next one is ketone. The functional group in ketone is CO, which is the carbonyl group. So the carbonyl group is bonded with two alkyl radical. forming RCOR. So here, if the compound is CH3 C double bond O CH3, then the name of the compound is dimethyl ketone. Here in ketone, the suffix used is ketone. Similarly, ethyl methyl ketone. If CH3 C double bond O is connected with C2H5, here one methyl group is connected with one ethyl group with a carbonyl group. So the name of the compound is ethyl methyl ketone. Now the next category, that is carboxylic acid. Here the carboxylic acid contains a COOH group, and the name of the compounds are formic acid for HCOH and acetic acid for CH3COOH. Similarly, propionic acid. There are many other common names. For example, if one double bond is present in the carboxylic acid, suppose this CH2 group is attached with CHC double bond OH, then the name of the compound is acrylic acid. Okay, so there are some dicarboxylic acid also. For example, if two carboxylic acid are attached with each other, C double bond OH is attached with C double bond OH, then the name of the compound is oxalic compound. If these two carboxylic acids are attached with one methyl group, then the name of the compound is malonic acid. Similarly, if two carboxylic acids are attached with ethyl group, then the name of the compound is succinic acid. Now move to the next category, that is acid derivatives. So these are the compounds which are obtained by the replacement of the hydroxyl part of the carbonyl group with other group. For example, the first one is acid chloride. In this, the OH group is replaced by the Cl chlorine group, and the functional group is R C double bond O Cl. These are the acid chloride, and the name of the compound is CH3COCl. This is named as acetyl chloride. Here the suffix used is yl chloride. Okay, here we can see that the suffix used is yl chloride. Similarly, propionyl chloride for C2H5COCl. Now the next one is amide, in which OH is replaced by NH2, and the functional group is R C double bond O NH2. The suffix used for this one is amide. So the name of the compounds are formamide, acetamide, and so on. Now the next category is ester, in which OH is replaced by OR. So the functional group is R C double bond O OR. Here the suffix used is ate. So for example, the name of the compounds are like this: HC double bond OCH3, and the name of the compound is methyl formate. Similarly, CH 3 C double bond O C2H5. So the name of the compound is ethyl acetate because this group is acetic acid and this is ethyl. Now the next one is acid anhydride in which OH is replaced by OCOR. So the suffix used in acetic anhydride is anhydride. So the first example is CH3CO which is bonded with another CH3CO which is linked with one oxygen because it is OCOR. So here the name of the compound is acetic anhydride. Similarly, here C2H5CO is bonded with C2H5CO which is bonded with one oxygen. So the name of the compound is propionic anhydride. Now the next category is amine. So amines are the derivatives of ammonia. So these are obtained by the replacement of one hydrogen atom from the ammonia by alkyl group. So here we can see that the formula for ammonia is NH3. So one hydrogen atom from ammonia is replaced by another alkyl group, for example CH3. So the compound is CH3NH2. So the name of the compound will be methylamine. If two hydrogens are replaced by an alkyl group, for example C2H5NH CH3. So the name of the compound will be ethyl methyl amine. Now the next category is cyanide. So cyanides are the compounds containing CN group attached to alkyl group. So the compound will be RCN and O-nitrile is used as a suffix. O-nitrile is used as a suffix. For example, CH3CN. So the name of the compound will be acetonitrile. Similarly, propionitrile for C2H5CN. Propionitrile is the name of this compound. Now the next category is isocyanides. So isocyanides are the compounds containing NC group attached with alkyl group. They are named as alkyl isocyanide. So they are named as alkyl isocyanide, or they are also known as alkane isonitrile. So let's take an example. CH3NC. So it can be named as methyl isocyanide because they are named as alkyl isocyanide, or it can also be named as methane isonitrile. Now some common names of aromatic compounds. So for naming the aromatic compounds, no special rules are required. They are named as the substituted benzene. So if a benzene ring is substituted with one methyl group, then the name of the compound is toluene. If benzene ring is substituted with hydroxyl group, then the name of the compound is phenol. If benzene ring is substituted with NH2 group, then the name of the compound is aniline. And if benzene ring is substituted with 1 carboxylic acid, then the name of the compound is benzenoic acid. Now, if the benzene ring is substituted with 2 methyl group, then the name of the compound is xylene. And if the second methyl group is present at ortho position, then the name of the compound is orthoxylene. And if the group is present at meta position, then the name of the compound is metaxylene. Now, similarly, if the group is present at para position, then the name of the compound is p-xylene or paraxylene. Now, similarly, if the benzene ring is substituted with 2 functional group, for example, 1 COOH group, carboxylic group, and 1 alcohol, then the name of the compound is phthalic acid. Similarly, if benzene ring is substituted with NO2 group or nitro group, then the name of the compound is nitrobenzene. So these are some examples of the common names of aromatic compounds. For more examples like this, please download our app from the Apple Store or Android Store. Now let's move to the IUPAC system of the nomenclature of organic compound. Now comes the IUPAC system, pronounced as IUPAC system. It is the International Union of Pure and Applied Chemistry. So, IUPAC system is the most modern and largely used system. It has a set of rules for naming the organic compounds on the basis of their structure. So, the name assigned on the basis of the latest IUPAC rules to an organic compound is known as its systematic name. So, there are some basic rules for naming the organic compounds. So, for naming the simple aliphatic compounds, the normal saturated hydrocarbons have been considered as the parent compound, and the other compounds are their derivatives obtained by the replacement of one or two hydrogen with the various functional group. So, we should prefer the long chain, which is known as the parent chain or the main chain of the compounds. So, each systematic name has 2 or 3 parts. So, the first part is the root words. So, the root words are the basic unit of the compound, which indicates the linear or continuous chain of the carbon atoms. So, this table shows the root words of the carbon compounds. So, if there are 1 carbon compound or 1 carbon atom, then the root word is meth. If 2 carbon atoms are linked, then the root word is eth. Similarly, for 3 carbons, prop, for 4 carbons, bute, 5 carbons, pent, 6 carbon, hex, 7 carbons, hept, 8 carbons, oct, 9 carbons, non, and 10 carbons, dec is used as a root word. These 10 are the most important root words. Now, if 11 carbons are linked, then the root word is undec. Similarly, dodec, tridec, tetradec, pentadec, hexadec. And if 20 carbon atoms are linked, then the root word is icos. If 30 carbons are linked, then the root word is triacont, tetraacont, and pentaacont similarly. Now comes the second part, that is the primary suffix. So here the primary suffix are added to the root word to show the saturation or the unsaturation in the carbon chain. Saturation means if the carbon compound is single bonded, and unsaturated means the carbon compound is either double bonded or triple bonded. So if the carbon compound is saturated compound, means only single bonds are present, then the primary suffix is ane, and the name of the compound will be alkane, like methane, ethane, propane, butane. Now if one double bond is present, then the suffix is ene, and the IUPAC name will be alkene, like ethene, propene, butene, and so on. If one triple bond is present, then the suffix will be "ine" and the IUPAC name will be alkyne. For example, methane is not present because here we can see that if methane has one carbon, so according to the general formula of alkyne, that is CnH2n minus 2. So C1H0, and here we can see that the valency of carbon is not satisfied, so methane is not possible. So here C2H2, that is the ethane group. Similarly, ethane, propane, butane. Now the unsaturated with two double bonds. So if two double bonds are present in a compound, then the primary suffix is adyne, and the IUPAC name will be alkadiene, like butadiene, pentadiene, hexadiene. Similarly, if two triple bonds are present, then the suffix will be adiene. So the name will be alkadiene. So for example, pentadiene, hexadiene. Now moving on, if unsaturated with three double bonds, then the suffix will be atriene and the name will be alkatriene, like butatriene if butane contains three triple bonds. So these are the primary suffix of the systematic name. Now move to the secondary suffix. So the secondary suffix are added after the primary suffix to indicate the presence of particular functional group. So the second suffix indicate the presence of functional group. So if the functional group is alcohol, that is OH group, then the suffix is ol, like methanol, ethanol. If functional group is CHO group, that is aldehyde, then the suffix uses al, like methanol, propanol, butanol. If the functional group is CO group, carbonyl group, then the suffix is on, like butanon, pentanon. If functional group is carboxylic acid, that is the COOH group, then the suffix used is oic acid. For example, methanoic acid, butanoic acid, propanoic acid. And if the functional group is sulfonic acid, that is SO3H group, then the suffix used will be sulfonic acid. For example, methyl sulfonic acid, CH3SO3H. This is the methyl sulfonic acid. Now, amine. Amine is the NH2 group. So, if amine group is present, then the suffix will be amine. For example, methylamine, propylamine. And here, if thioalcohol is present, thioalcohol means the SH group, then the suffix will be thiol. For example, methyl thiol, yeah, methiol. If the functional group is cyanide, that is CN. So if CN is attached, then the suffix will be nitrile. For example, methane nitrile. If ester is present, ester means COOR group, then the suffix will be OAte. For example, methanoate. Now, if amide group is present, amide means CONH2, then the suffix will be amide. For example, acetamide, ethanamide, methanamide. Now, if the functional group is acid halide, acid halide means C double bond O X group, then the suffix will be oil halide. For example, methanol chloride. If the compound is CH3 C double bond O Cl. Okay, so the arrangement of the compound will be, first prefix is added, so prefix plus the root word plus the primary suffix plus the secondary suffix. Prefix is used for some substituent group. For example, the halides like chloro, bromo, ido, and some other substituents like nitro group or nitroso group. Let's understand this by taking this example. Here we can see that the root word for this compound will be bute, because 4 carbon atoms are present in this. And the prefix for this compound will be bromo, because the substituent group is bromine. So the prefix will be bromo plus root word will be bute plus primary suffix. So here we can see that this compound is single bonded, or we can say that this saturated, and we know that the primary suffix for saturated compound is ane, and the secondary suffix, here the functional group present in the compound is carboxylic acid, and we know that the suffix for carboxylic acid is oic acid. So the secondary suffix will be oic acid. So the name of the compound is bromo butanoic acid. Now, in IUPAC system, the position of substituent group is also important. So here we can see that the substituent group is present at 1, 2, 3 carbon, third carbon. Okay, so the name of the compound will be 3-bromobutanoic acid. Now let's move to the rules of IUPAC name of the complex compound. So first we will discuss the naming of the aliphatic compounds when no functional group is present in the compound. So here the first rule is to find the longest chain. So for naming the compound, the first step is to find the longest chain, which is called the parent chain or the main chain. Now the second one is the numbering of carbon atoms. Now for numbering the carbon atoms, the first substituent group attached to the carbon chain should get the lowest number. So the substituent group gets the lowest number. Now the second thing is if there are same substituent group present in the compound. For example, 2 methyl groups are present, then di is used. If 3 methyl groups are present, then tri is used. Similarly, tetra is used for 4 similar substituent group. Now if there are many substituent group is present, then lowest sum rule is followed. Let's understand this by an example. So if the compound is CH3, CH, CH, CH2, CH2, sorry, CH, CH3. Now here the second carbon is attached with CH, CH3. This one is also CH3 and the fifth one is also attached with CH3. Now here we can see that it can the longest chain will be 1, 2, 3, 4, 5, 6. Okay, so here 1, 2, 3, 4, 5, 6. The substituent groups are present at second plus third plus fifth carbon. So the sum will be 2, 3, 5 is 10. Now if we number this chain from this side, so here 1, 2, 3, 4, 5, 6. In this case, the substituent groups are present at second, fourth and fifth carbon. So the sum will be 9 plus 2, 11. So here we can see that the lowest sum is this one. So this particular chain is preferred and the numbering start from this carbon. Now the third rule is naming in the alphabetical order. So we will always name the compound in alphabetical order. For example, ethyl is substituted first before methyl. Now let's solve some examples. So here we can see that the longest chain will be this chain, this straight chain. Now we can see that if we start numbering from this carbon atom, then we can see that the ethyl group will be present at third carbon. And if we start numbering from this carbon atom, then methyl group is present at this carbon. So here both the substituent group are present at third carbon. But in this case, according to the rule, the alkyl group, which is the first in alphabetical order, should get the lower number. So here ethyl should get the lower number. So numbering starts from this side. So it is 1, 2, 3, 4, 5, 6, 7. So this is the long chain. Now numbering starts from this carbon because ethyl group should get the lowest number because it is first in the alphabetical order. Now naming in the alphabetical order. So the name of the compound will be 3-ethyl, then 5-methyl, and the root word will be hept. The primary suffix will be ane, and there is no secondary suffix because no functional group is present. So the name of the compound is 3-ethyl 5-methyl heptane. Now similarly for this carbon chain. Now here we can see that in this case one complex chain is present as a substituent group. So it is numbered differently. Here we can see that the substituent group is present at third carbon. So the longest chain will be 1, 2, 3, 4, 5, 6, 7 and 8. Now here at third position a complex chain is present and the chain is 1, 2, 3. So it is represented by 1 dash, 2 dash and 3 dash. So at third position we can see that 2-methyl, 2 dash methyl, and this is a propyl because it contains 3 carbon atoms. So 2-methyl propyl is attached with third carbon of the main chain, and the root word is oct because there are 8 carbon and ane is used as a primary suffix. There is no secondary suffix because no functional group is present in the compound. Now let's move to the second category, that is the naming of unsaturated aliphatic compounds when no functional group is present. So here the first rule is finding the longest chain. The second rule is it must have maximum double or triple bond. And the third rule is numbering of carbon chain. So let's take an example. So here we can see that the longest chain is 1, 2, 3, 4, 5, 6. It contains 6 carbon atoms. And here 1, 2, 3, 4, 5, 6, 7. So here there are 7 carbon atoms. But in this case, this carbon chain is preferred for the name of compound because it has the maximum double or triple bond. So here the name of the compound will be the third rule is numbering of carbon chain. So here we can see that if we start numbering from this side, we can see that the double bond will get the second position. But from this side, the double bond will get the first position. So the numbering will start from this side. So the numbering will be 1, 2, 3, 4, 5 and 6. So here we can see that at third carbon 1, 2, 3 propyl group is present, and the root name will be hex, and there are 2 double bonds. So hex 2, 4 diene. because diene is the suffix for two double bonds. So the name of the compound is 3-propyl hex 2,4-diene. Now move to the next category, that is the naming of aliphatic compounds when functional group is present in the compound. Now the first rule is finding the longest chain. So first we will find the longest carbon chain which include all the functional group. Okay, so all the functional group will be included in the longest chain. Now the second one is numbering of carbon chain. The numbering of parent carbon chain is done in such a manner that the carbon linking with functional group gets the lowest number. Okay, so the functional group will get the lowest number. Okay, and what if there are more than one functional group? In this case, we will follow the priority table. So if there are more than one functional group present, it follows the priority table, and the priority table is given as follows. Here we can see that sulfonic acid has high priority than carboxylic acid, which is greater than ester and acid chloride or acid halide, then amide, cyanide, isocyanide, aldehyde, ketone, alcohol, thiol, then amine, then ether, then double bond, triple bond, azide, nitro group, nitroso group, and halides group. So if more than two functional group are present, then priority table is used and prefix is used for the name of functional group having the least priority, and the root name, or we can say the secondary suffix, will be the suffix for functional group having the highest priority. Let's understand this with an example. Here we can see that this compound have two functional group. One is alcohol group and the second one is carboxylic group. Now we can see that in the priority table, carboxylic acid has the highest priority. So the numbering starts from this carbon 1, 2, 3, 4 and 5. Now prefix is used for the name of functional group having least priority, and the prefix for alcoholic group is hydroxy. So here it can be named as 4-hydroxy. Here the root name is pent and the primary suffix is ane because it is singly bonded, and the secondary suffix is oic acid because the highest priority is for carboxylic acid. So it is pentanoic acid. So the name of the compound is 4-hydroxy pentanoic acid. Now move to the next category, that is the naming of Elecyclic compounds. So in Elecyclic compounds there are two categories. So if the cyclic compound contains more carbon atom than the alkyl group, then the alkyl group is considered as the substituent group. For example, here we can see that here The cyclic group is cyclobutane, and the alkyl group is CH2, CH2, CH3. Here we can see that in alkyl group, 3 carbon atoms are present, and in cyclic compound, 4 carbon atoms are present. So, this alkyl group will act as substituent group, and the name of the compound is propyl cyclobutane, because the cyclic compound will be the parent chain. This is the first case. Now, the second case. If cyclic compound contains less carbon atoms than the alkyl group, then in this case, the cyclic compound will considered as the substituent group. For example, here the alkyl group is CH3, CH, CH2, CH3. Here this carbon is attached with cyclopropane. So here we can see that in cyclic compound 3 carbon atoms are present, and in alkyl group 4 carbon atoms are present. So this cyclic compound is considered as substituent, and the name of the compound will be 1, 2, 3, 4. So 2 cyclopropyl butane. So let's take some examples. Here we need to find the IUPAC name of the given compounds. So here this one is the first compound. Here we can see that the longest chain will be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. But according to the rule, longest chain must have the double bond or triple bond. So the chain will be 1, 2, 3, 4, 5 and 6. Now the substituent group at third carbon is 1, 2, 3 propyl group, and at fourth carbon is 1, 2 ethyl group, and we will name the compound in alphabetical order. So the name of the compound is 4 ethyl 3 propyl. Here the root name is hex. The suffix is "ene" because one double bond is present at first carbon, and the position of double bond is 1. So the name of the compound is 4-ethyl 3-propyl hex 1-ene. Now the second one. Here we can see that the alkyl group have 2 carbon, and the cyclic compound contains 4 carbon. So the alkyl group will be the substituent group. Now we know that the numbering starts from the carbon atom having the functional group. So here functional group is present at this carbon. So the numbering starts from this carbon 1. Now the second priority is for double bond rather than the substituent group. So this carbon is not numbered as second carbon. This carbon is numbered as second carbon. So 1, 2, 3, 4. Now here we can see that at fourth position ethyl group is present. So 4-ethyl cyclobute. Here the primary suffix is "ene" because one double bond is present. It is present at second position. So cyclobute 2-ene, and ol is the secondary prefix because this is the functional group and it is present at first carbon. So ol is used as a suffix. So the name of the compound is 4-ethyl cyclobute 2-ene-1-ol. Now moving to the third example. Here we can see that there are more than two functional group present in the compound. So priority table is followed and we can see that the priority of cyanide is highest in this case. So the numbering starts from cyanide. So 1, 2, 3, 4, 5, 6. It is not 1, 2, 3 because in this case the functional group will get the number 3 which is higher than 2. So the name of the compound will be in alphabetical order like 2-bromo. Prefix is used for the least priority functional group. So least priority functional group is alcohol and the prefix for alcohol is hydroxy which is present at fifth carbon. So 2-bromo 5-hydroxy benzonitrile because the suffix for cyanide is O-nitrile. So benzonitrile. So the name of the compound is 2-bromo 5-hydroxy benzonitrile. Now the fourth example. Here we can see that the numbering starts from the carbon atom having functional group. Here the functional group is alcohol. So numbering starts from this carbon 1, 2, 3, 4, 5 and 6. Now the name of the compound in alphabetical order will be here at third carbon 2 methyl groups are present. So the name of the compound is 3,3 dimethyl. The root word for the chain is cyclohexane. So cyclohexane and the functional group is alcohol and suffix used will be ol which is present at first carbon. So the name of the compound is 3,3-dimethyl cyclohexane 1-ol or hexanol. Now the fifth example. Here in fifth example we can see that acid chloride is present. So the name of the compound is benzenoyl chloride because the suffix used for acid chloride or acid halide is oil halide or chloride we can say. So the name of the compound is benzenoyl chloride. Now the sixth example. This one is the complicated one. Here we can see the carbon chain. So the numbering starts from this carbon 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we can see that at fifth carbon one complex compound is present. So we will name this substituent group differently. So here it will be 1 dash, 2 dash and 3 dash. So we will name this compound in alphabetical order. At second carbon 2 methyl groups are present. So the name of the compound is 2,2 dimethyl. At fifth carbon 1, 1, 1 dash, 1 dash, 2 dash trimethyl are present. Okay. And it contains 3 carbon atoms. So it is 1, 1, 2 trimethyl propyl, and the root name will be non and the suffix will be ane because it is single bonded. So the name of the compound is 2,2 dimethyl 5 1 dash 1 dash 2 dash trimethyl propyl nonane. So these are some examples of IUPAC names of the compound. For more practice question, please download our app from Apple Store or Android Store. So that's all for today's lecture. I hope you understood the chapter clearly. For all the video lecture on organic chemistry, please subscribe to our chemistry course in the website. And for more practice question, please download the app from Android Store or Apple Store. In the next lecture, we will be discussing the isomerism of organic compound. Hope to see you in the next lecture. Thank you.